Good day, everyone, and welcome to today's lecture. Building on our earlier discussion about acquiring technology, we now turn our attention to a critical yet often underestimated aspect of the process: evaluation and control. While the act of acquiring new technology is inherently strategic and forward-thinking, its ultimate success hinges on how well we assess, monitor, and refine both the acquisition itself and its subsequent implementation. Without a structured approach to evaluation and control, even the most promising technological investments can devolve into costly missteps, inefficiencies, or outright failures. Let us begin by addressing a fundamental question. When and where should evaluation and control take place during the process of technology acquisition? The answer is straightforward but profound. Evaluation and control must be integrated at every stage of the journey. These are not tasks to be relegated to the final phases of a project. Rather, they are ongoing practices that should be embedded from the very beginning, during the planning phase, throughout the integration process, and continuing well after implementation. The importance of continuous evaluation and control evaluation serves as the compass that ensures the acquisition remains aligned with the organization's overarching strategic objectives. It provides the clarity needed to determine whether the technology is meeting expectations and delivering its intended value. On the other hand, control acts as the steering mechanism, enabling timely interventions whenever deviations from the plan arise. Together, these functions form the backbone of responsible technology management. For instance, imagine a company investing in a new software platform. The evaluation process should commence as early as the selection stage, focusing on key factors such as technical compatibility, projected cost-benefit analysis, and cultural fit within the organization. As the project progresses to the implementation phase, evaluation should shift to monitoring adoption rates, identifying integration challenges, and tracking progress against defined milestones. Even after the technology has been fully deployed, ongoing evaluation remains crucial to ensure it continues to deliver value, stays secure, and evolves in response to shifting business needs. The role of organizational capabilities in technology acquisition. Acquiring technology is not merely a matter of financial investment, it demands a high degree of organizational capability. Some companies excel at identifying cutting-edge technologies but struggle to integrate them effectively into their operations. Others may have the technical expertise to manage new systems but lack the strategic foresight or relational skills to navigate partnerships and alliances. Two critical capabilities stand out in this context. One, strategic alignment capability. This refers to an organization's ability to identify and evaluate technologies or partners that align seamlessly with its long-term business strategy. Acquiring technology that clashes with an organization's operational model, cultural norms, or market trajectory can lead to significant friction, undermining the entire investment. 2. Integration capability. Equally important is the organization's capacity to absorb and utilize the new technology effectively. This encompasses technical expertise, robust change management processes, adaptable IT infrastructure, and strong leadership support. Without these elements in place, even the most advanced technology can end up underutilized or improperly implemented, leading to wasted potential. A concept worth highlighting here is absorptive capacity, an organization's ability to recognize the value of external knowledge, assimilate it, and apply it to achieve competitive advantage. Companies that cultivate this capacity are better equipped to manage acquisitions and alliances, transforming them into powerful drivers of innovation and growth. Gap analysis, a key tool for evaluation. One of the most effective techniques for evaluation in the context of technology acquisition is gap analysis. This method allows organizations to compare their current state with their desired future state, highlighting discrepancies that need to be addressed. In the realm of technology, gap analysis can uncover critical shortfalls in performance, functionality, cost efficiency, usability, or alignment with strategic objectives. Consider the example of a logistics company that implements a real-time tracking system to improve its operations. Post-implementation, a gap analysis might reveal that while the system performs exceptionally well in urban areas, it falls short in rural regions due to connectivity issues. This insight enables the company to target specific improvements, such as investing in satellite-based solutions or enhancing mobile network partnerships. Gap analysis is equally valuable for identifying internal challenges, such as gaps in employee competence, deficiencies in support systems, or misalignments between different departments. These findings provide essential input for designing control measures and shaping future investment decisions. Measuring performance and avoiding escalation of commitment. A cornerstone of effective evaluation is the establishment of clear key performance indicators, KPIs, from the outset. These metrics act as benchmarks against which the success of the technology acquisition can be measured. Depending on the nature of the project, KPIs might include return on investment, ROI, the user adoption rates, the system uptime or operational speed improvements, cost savings, or customer satisfaction scores. To be effective, KPIs must be realistic, directly relevant to the organization's goals, and subject to regular review. However, even with robust performance metrics in place, organizations can fall prey to the psychological trap of escalation of commitment, the tendency to continue investing in a failing project due to the resources, time, or reputation already committed. This mindset is often encapsulated in statements like, "We've already invested too much to stop now," or "Let's give it just one more chance." To counteract this tendency, organizations should establish predefined exit criteria or kill points before the project begins. These are specific checkpoints at which the project's progress will be reassessed, and if it fails to meet expectations, it will either be discontinued or significantly restructured. External reviews, third-party audits, or advisory boards can provide additional objectivity during these critical evaluations. Feedback, the foundation for continuous improvement. The final, yet arguably most important, component of evaluation and control is the systematic collection and application of feedback. Every technology acquisition should be viewed as an opportunity to learn and improve. Conducting thorough post-acquisition reviews allows organizations to capture invaluable lessons, what worked, what didn't, and how similar initiatives can be managed more effectively in the future. Feedback should be solicited from a wide range of stakeholders, including executives, project managers, IT personnel, end users, and even external partners. This diverse input fits into an organizational learning system, informing playbooks, training programs, policy updates, and decision-making frameworks. Some key questions to consider during post-acquisition reviews include: were the original goals clearly articulated and achievable? Did we select the right vendor or partner for the project? Were users adequately engaged and supported throughout the process? Did unexpected technical or cultural challenges arise? How effective was our integration plan in practice? By embracing a culture of continuous learning, organizations can become more agile and resilient. In today's rapidly evolving technological landscape, the ability to adapt and improve is often more valuable than having a flawless initial plan. Conclusion: in summary, evaluation and control are not mere administrative formalities, they are the cornerstones of responsible and effective technology management. By embedding these practices at every stage of the acquisition process, organizations gain the visibility, discipline, and adaptability necessary to succeed. Developing capabilities such as strategic alignment, integration proficiency, and absorptive capacity further enhances an organization's ability to not only acquire technology but to master it. Through tools like gap analysis, clearly defined KPIs, and robust feedback mechanisms, companies can navigate the complexities of technology acquisition with confidence. And by resisting the pull of sunk costs and fostering a learning-oriented mindset, they position themselves to thrive in an era of constant innovation. Thank you for your attention today. In our next session, we will delve into risk management in innovation projects, exploring how to navigate the uncertainties that accompany bold technological advancements.